traveling with parents. We're going to continue working on our transformations here. We'll be using a little bit of calculator here to see some of those transformations. Let's go ahead and get started. On the first one, number 1, they want us to consider the parent function y equals the square root of x. And we're going to see that function on the domain x is greater than or equal to 0. Now at this point, guys, we had a test. Our first test dealt with our parent functions. And at this point, everybody in here should already know what the graph of y equals the square root of x looks like, right? Anybody know what it looks like? It's a curve. Where does it start at? 0. Remember, it starts at 0, 0, then it curves to the right. So that's what we're going to graph on our graph paper. However, we want to make sure this graph is as accurate as possible. So what we're going to do is we're going to take out this x that we have, and we're going to replace it with these x values they gave me in the table. All right, so let's start with 0. If I replace x with a 0, anybody know what the square root of 0 is? 0. So let's put that in our table. What about 1? Anybody know what the square root of 1 is? 1. The square root of 4. The square root of 4 is 2. And finally, the square root of 9 is 3. So what I'm going to do is I'm going to use these order pairs to get myself a graph. So 0, 0 is this point right here. Then I have 1, 1. Then I have 4, 2. Then I have 9, 3. Once I have these 4 points, I'm going to connect the dots. And there's the graph that we end up with. So that's the graph of y equals the square root of x. You guys should already know what that looks like. Right below that, they want to know what is the range of this graph. Range are the y values. What kind of y values do we have on this graph?
0, 1, 2, 3.
0, 1, 2, 3. Well, yes and no. Yes, those are some of the y values. But does it really stop at 3? No. I could also include 4, 5, 10, 50, 100. What do I need to say here? I want to include all those numbers. All the numbers that are greater than a 0. Do I also want to include the 0? Yes. So what we're going to say is, that's right. We're going to say that the y values on this particular graph are everything that is greater than or equal to a 0.
It's not lying.
This is the notation we're going to use. And all this is saying is y such that the y's are greater than or equal to a 0. So in this particular graph, all the y values start at 0, and from there they just get larger, 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 and larger, and larger. Now what we're going to do is we're going to take one of those map colors I asked you to grab. Right here it says use a different color. And what we're going to do is we're going to take this parent function, and we're going to translate it -3 units vertical. So take your different map color there, and let's translate this thing -3 units vertical. And when they say -3 units vertical, what the heck are they asking me to do?
3 units down.
Move it 3 units down. How do you know down?
Because it says negative.
Because it says negative. Had it been a +3, then that would have moved up. Okay, so we're going to move this thing down 3 units. And that's very easy to do, guys. All we're going to do is take each of these points that we put on there earlier and just move each of those points down 3 units. So right here, starting with this, move it down 1, 2, 3. So now it's here. Take this point, move it down 3. 1, 2, 3. Take this one and move it down 3. 1, 2, 3. And do the same thing with the last one. 1, 2, 3. Once you have all the points, connect the dots. And there it is. You got yourself your new graph. Notice how it's exactly the same shape. All we did was slide it down 3 units. All right, with that said, now let's take a look at that graph and identify the domain and the range of this new function. Domain. Domain is exactly the same domain as the original, which they gave us. The domain is right here. It's all the x values that are greater than or equal to 0. Let's start there. X is greater than or equal to a 0. The y values, though, those numbers have changed. Because remember, what did we do to the graph? We moved it down 3 units. So it's no longer starting at 0 anymore. Now it's starting at a -3. And from that -3, Are the y values getting bigger or smaller than that negative 3?
Bigger.
Bigger. So we want to show that. So we're going to say that the y values are greater than or equal to a negative 3. The next thing they want me to do is write the equation of this new graph. In other words, if I wanted to put this in the calculator, what do I have to put in the calculator in order to get this red graph? Well, and y equals. I know I got the same shape, so I'm going to need the square root of x. So we move the graph down 3. And to show that, if I want to move the graph down, what do I have to do? Subtract. In this case, how much are we subtracting? 3. So I want to show that in my equation. So the equation we're going to end up with is y equals the square root of x minus 3. Notice how the minus 3 is on the outside of the square root. It's like being on the outside of the parentheses. So that's the equation of this new graph.
Going down.
That's what, that minus 3 is what moved the graph down 3 units. Let's get a different color now. Let's get a third color. And this time what we're going to do is we're going to take the parent function and we're going to reflect it over the x-axis. Reflection means what? Flip. That's what we're going to do. We're going to flip this black graph, which is our parent function. We're going to flip it over the x-axis. All right, so we're going to start right here with this point. Notice how it's on the x-axis? So it's actually going to stay right where it's at. This point, though, we need to flip it. Right now it's on the top of the x-axis. When we flip it, now it's going to be down here at the bottom of the x-axis. Notice the spacing is the same. Then I come to this point over here. Got to flip it. So instead of being on the top of the x-axis, now it's below the x-axis. Same thing with this point over here. It's on top. I need to move it to the bottom. So when I connect the points, there's the new graph. Notice all I did was flip that thing upside down. All right, so the domain. What's the domain of this graph? Saying, well, it's still the same. It's still x is greater than or equal to 0. X values are still the same. Y values, on the other hand, those y values have changed now. We're looking at the green graph. Where do the y values start? Where does this graph start at? 0. Notice how it still starts at 0. But notice what's happening to the graph this time. Are the y values getting smaller or bigger than that 0? Smaller. So we want to show that in our range. So we're going to say that the y values are not greater than, but less than or equal to 0. Less than or equal to 0. This would be our range. Now I need the equation. Remember what we did to this graph is we flipped it. And in order to get a flip or a reflection, we need a negative sign. The question is, where does that negative sign need to go? Does it need to go in front of the function, or does it need to go next to the x? In front of the function. All right, so the equation should be y equals negative square root of x. Y equals negative square root of x. So flip over that. And it's going to flip over the x-axis. Now do me a favor, guys. Everybody go to your calculator real quick. We're going to check this out. In y equals, what I need to do is in y equals type in negative square root of x. Type in negative square root of x. Graph it. And what you should see is this graph that we got right here. Everybody gets this graph, correct? Here's what I want you to do now. You do something a little bit different. Go back to y equals again. Delete what you typed in earlier. And this time what I want you to do is type in square roots and then the negative x. The negative next to the x. Graph it. Whoa. And look what happens this time. You don't get the same graph, do you? What happened this time?
On the other side.
Well, it's on the other side of what?
Y.
The y-axis. So this time what happened is, we have a reflection over the y-axis. Is that what's supposed to happen? Yes, according to the notes that we just took. Whenever we have that negative sign next to the x, we should have a reflection over the y-axis, which is exactly what happens here. So, on the test that we got coming up, one of the things is you'll be given a graph, and then you're going to have to write me the equation. Is it going to be important where the negative sign goes? Yes. But be very careful where you put the negative sign when you're talking reflection. Okay, that takes us to the first one. Let's take a look at the second one. Number 2. Number 2, now we're working with a exponential. Y is equal to 2 to the x power. What we're going to do is complete a table and sketch the graph. So we're going to take out the x that you see there, and we're going to replace it with all of these x values in the table. Now to do that, you may need your calculator. So have your calculator handy. You don't need to be in y equals. You can go to a nice clean screen, or your screen. And we're going to start with 2 to the negative 1 power. Put that in your calculator for me. What is 2 to the negative 1 power? 0.5. So write that down in your table, 0.5. Then we're going to do 2 to the 0 power. Put that in your calculator. 2 to the 0 power is a 1. Then we're going to do 2 to the first power. You should know that one. 2 to the first power is just a 2. 2 squared. 2 squared should give you a 4. And then finally, 2 to the third power. 2 to the third power is going to give you 8. 2 to the third power is 8. So there's your table. Now we're going to graph each of these points, and let's see what happens. Negative 1.5. Negative 1.5. Right here. Then I have 0, 1. Then I have the ordered pair 1, 2. Then I had 2, 4. Then I had 3, 8. I'm going to go ahead and connect these dots. This graph that we get should look familiar to you guys. It was on our first test. That right there is the graph of our exponential. And that's our parent function. Exponential growth, correct. Now right below that, that exponential growth, they want me to identify the range, the y values. Well, the first thing I want to point out is notice that this graph stays above the x-axis. It never drops below it, which means our y values are always going to be what kind of a number? Positive. So that's what I want to say here. They all stay positive values. So we're going to say that the y values are all greater than a 0. Y values are greater than 0. By the way, notice there is no equal sign there. That's right. It doesn't go to 0. It stays above it. It stays above the x-axis. It never crosses it. As a matter of fact, it never touches it. So that's our range for this particular graph. What we're going to do now is going to grab a different color. Grab a different color. And let's see what we want now.
No, like that. Very common for Rob. I'm sure you fix it for me.
This time what they want me to do is they want me to take the y values of that parent function and multiply them by a 0.25. So everybody get your calculator. We're going to need a little help here. They're asking me to take all these y values that you see here and multiply them by a 0.25. So let's start with 0.5. What's 0.5 times a 0.25? 0.125. Now let's do the 1. When you multiply 1 times a 0.25, you're going to get a 0.25. 2. What do you get when you multiply 2 times a 0.25? 0.5. 4. 4 times a 0.25 is a... Is that right? 1? Should be right. And then 8. When you multiply 8 times a 0.25, you're going to get a 2. So these are the new y values. So what we're going to do is we're going to come over here and plot these new points. So here we go. The first one is negative 1, positive 0.125. So let's find that one. Just barely above the line. The next order pair we had is 0.25. 0.25 is just a little bit higher than that first automation. Then I have, what's the next one? 1 and 0.5. Should be right in the middle there. Then I have the order pair 2, 1. It's right here, 2, 1. And then finally I have 3, 2. So these are the new points. This is what I get after I multiply the y value by 0.25. So let me connect the dots so you can see what we're working with. All right, so there's our new graph. That's the new graph. Domain stays the same. In this case, what is the domain? Tells you right here. Domain is all real numbers. And you can use this symbol right here, guys, to show all real numbers. All real numbers. Let's talk about the range now, the y values. Notice this graph is a lot like the first graph. Notice how it also stays right above the x-axis. This never dips below the x-axis, which means we have what kind of numbers here? Y is still greater than a 0.
So it's going to be the same.
It's going to be the same exact thing. The y values are still greater than 0. Notice it's not equal to, but it's still not touching that x-axis. Here comes the tricky part, writing the equation of this new graph. What do I have to type in my calculator in order to see this graph right here? Think about what we did. They told us to take the y values and multiply them by 0.25. So I have to show that in my equation. What am I going to write so I show that I multiply the y value by a 0.25? Y equals
Plus y x times 2.5.
Say it again?
I mean, 0.25.
I think I heard.
Yeah,
Should have y equals
exactly.
0.25. That's the number we're multiplying by. Times 2 to the x power, which is our parent function. That's going to be this one right here. Well, in this case it's half, but it could have been 1/4. Anything between 0 and 1 would be this right here. Okay? So what's happening here is we're taking the original parent function, and what we're doing is we are compressing it. Okay? We're like stepping on this thing and squashing it down, which is why it's looking like this red one. That's what's happening. All right, we got one last one to look at. That's C. Take a third color, and this time we're going to take the parent function and translate it down. Actually, let's see, translate 1 unit vertically. So if we're going to translate this 1 unit vertically, what do they need me to do?
From the black one, right?
Yeah, we're looking at the black.
You just go up.
We're going to go up 1. So each of these points that we made earlier, we're just going to move them up 1. So this one now comes up here. This one comes up here. This point comes up 1. This one comes up 1 unit. This one also comes up 1 unit. All right, so the graph is now looking like that. Okay, so all we did was move the graph up 1 unit. Still the same shape. So if that's true, domain. Is the domain going to change any? No, it's still going to be all real numbers. That has not changed. Range has changed. The y values, it's changed a little bit here. What is the range? What are the y values this time? On the other ones, we said it was greater than 0. But what did we do? Didn't we move this graph? That's right. We moved it up 1. So now instead of being at 0, now it's at 1. So the y values have to be greater than a 1. And that's because we moved it up 1 unit. And the last one there, write an equation for this new graph. We want to show the fact that we move the graph up 1 unit. So if I want to move up 1 unit, I got to do what? Add. In this case, I'm adding how much? 1. Right? So what we should have is y equals 2 to the x power plus 1. Again, that plus 1 is what's moving the graph up 1 year. Alright, so that takes care of traveling with parents. Traveling with parents.